What's going on? I'm Anastasio Dalde. This is SDG Labs. I'm the world's best dad, hands down. I've got a shirt that says so. You ever do this? You ever go to the beach and you gotta go walk all the way down to the ocean? I think that when I go to Waimea, it's so far and the sand is so hot that when I carry the big cooler, what I usually do is I take my son's boogie board and I put it on top of the cooler on top of the boogie board, and I just pull the leash like a sled or something like that. I do it all the time. So check this out. Let's pretend that there are, let's pretend that there's little wheels on this. So I have kind of a sled or maybe a skateboard. I have a skateboard and I put a cooler on top. So the mass of this whole system right here, let's pretend that that's equal to 4.6 kilograms. And my question is, if I pull with a force of 6.20 newtons at an angle of 35 degrees, what is my acceleration? And then also, what is my velocity if I'm pulling it for time 1.15 seconds, I believe. All right. So here's what we do. What I'm going to do is I'm going to take a vector and break it up into its components, because that's what I always do when I have vectors and components. I'm going to call this force, I'm going to call this force y, and I'll call this one force x. Here's theta over here, which we know is 35. Force is actually 6.2. So force y is equal to force, that would be the sine of theta. This is equal to force cosine theta. And there, I've broken it up into its components. Now what I'm going to do is I'm going to do some of the forces in the y direction. Well, some of the forces in the y direction, the question is this thing accelerating in the y direction? And my answer is hopefully no, because that would mean this thing is actually going up. It's not really rising into the air, it's just being dragged across this thing. The only forces that I happen to see are actually, so I told you that I want that to equal to 0. The only forces I happen to see, and I actually forgot to draw in a force over here, since it has a mass, it has a weight associated with it. That weight happens to equal mass times gravity, so whatever mass times gravity is that. So let's see, mass times gravity is 4.6 times 9.8. And then you have to, so that would be negative mg plus fy, because that's the other force that's going in the y direction, equals 0. So hopefully, and I'm not sure, I actually didn't check this, but fy equals mg. I just take that and put that on the other side. I didn't check that, so I don't know. But what I wanted to do is I wanted to calculate the acceleration in the x direction. So let's do a sum of the forces in the x direction is equal to mass times acceleration. Is it accelerating in the x direction? Yes, it is accelerating in the x direction. It shouldn't be accelerating in the y direction, because that means it's going up and down. But this one, it means it's going forward and backwards, which is what we want. The acceleration in the y direction, x direction, let's figure out what that is. Well, what force do we see? Well, we see force of x, and that's the only x direction force I see. I'm assuming that there's no friction. That's why I have these things on a skateboard. So I have f cosine theta is equal to max. And let's see, I know f, that's 6.2. I know theta, that's 35. And just divide by m. Now a is equal to force cosine theta over m. If you calculate that out, you'll end up getting 1.10 meters per second squared. Now, how do I figure out the velocity that it has after it's traveled for t equals 1.15 seconds? Well, for that, we turn back to our old school kinematics, and we basically want to find v final. We know the acceleration, we have the time, and we know the v initial. I'm going to assume that the v initial is 0. So yes, we have it. So v final is equal to v naught plus at. This is 0. You just take this a, you multiply it by that time, and you end up getting 1.27 meters per second. Shoots, bro! Up out!